Welcome, my name is Josh Burleson, and this is an introduction to all of the UI and UX related technologies that you will be utilizing next week. If you're not aware, next week you'll be attending ACE, or the Associate Consultant Enablement, and you'll be put through a mock client engagement. So what that means is we have a fake project set up for you. You're going to have a client, a working product, and a working code base. So make sure that you pay attention because you'll be using all of these concepts next week. If you have any questions regarding this video, ACE, or Red Hat in general, feel free to reach out to me at any of the mediums listed below. So let's take a look at what we're going to be covering in this video. First up, we have web app communication. This is on how the UI talks to the rest of our code, which is running on our server, and accesses the data in our database. Then we're going to talk a little bit about Node.js. There is actually a static HTTP server in our code base that you will run and use locally whenever you're doing any UI and UX development. Then we're going to go over some key concepts of AngularJS and see how those concepts apply to our code base. Lastly, we're going to go over JavaScript as a language and cover an interesting concept called promises, which we do utilize in the lab. So I hope by now that you've heard of HTTP, or rather Hypertext Transfer Protocol. It is a protocol that is a means to standardize communication between different pieces of the internet. REST, or Representational State Transfer, is a methodology that uses HTTP and establishes a standard for building out APIs around 4 CRUD operations: create, read, update, and delete. So how does that translate into an API code base? Well, for each data set that you want to expose, you'll actually have a function for each one of those operations. And finally, we have JSON, or JavaScript Object Notation. This is the format in which we package up our data so that it can be sent across HTTP using REST endpoints. So at the bottom here, we have a series of events to try and help you understand how all these different pieces work together. First, let's say a user clicks a button on a website and requests some information. That click fires off what is called an AJAX request, which stands for Asynchronous JSON and XML. So that AJAX request sends some JSON over to our CAML endpoints, which are REST endpoints, down the CAML routes in our server, and accesses some data in our database. So let's add a few more pieces to the puzzle and take a high-level view of our product in a little thing I like to call a 3-box diagram. Essentially, every web application ever consists of these 3 pieces. You have your browser, which is running in your laptop or PC locally. You have your server or web server running out in the cloud, and obviously a database that stores all of your persisted information. So I'm going to ask you to do a Dora the Explorer and pause the video and try and see if you can place each of the technologies in their corresponding box. Alright, if you didn't pause your video, you suck and you're no fun. Either way, we're going to go over them. So all of your AngularJS code, all of your CSS, HTML, and your AJAX requests are all being executed on your browser. I do want to note, however, that the files originally come from the web server. So your static files, your JavaScript, CSS, HTML, are hosted on your web server. Your browser will hit that web server, get the files, and then run them. Then over on your server side, you have Apache Tomcat. So this is your actual web server. And on that server, you have your BRMS rules running, all of your Java code, and your CAML API endpoints. Then of course we have MongoDB as our database, which stores data in the form of documents, which are basically displayed as JSON. And finally, we have the communication between each of these pieces. It's all HTTP traffic being performed via AJAX requests, REST endpoints, and that data is packaged up as JSON. All right, now let's take a look at Node.js. If you're unfamiliar with it, it is a cross-platform runtime environment for executing server-side JavaScript. Think of it as the JVM for JavaScript. You see, traditionally, JavaScript only ever ran in your browser, and then some very smart people came along and they extracted the JavaScript processing engine out of Google Chrome and then built an entire runtime environment around it so that JavaScript could, for the first time, be executed on any server regardless of hardware. So what that essentially means is that anything that you would write in Java or C or Python can be done in Node.js. Whether that is standing up API endpoints, you can build a REST API very easily with Node. Whether that is writing code that accesses your database or is your core business logic or your business rules, all of that can be done in Node.js. So let's take a look at our Node server that we're using in our app. Notice that it's only about 15 actual lines of code here, but that's all you need to set up a static HTTP server. Node is a very robust language, and there have been tons and tons of packages written for it because it's open source. So essentially you can get a lot done in Node without having to write too much code. So this server is super simple, and we're only going to be using it for UI development purposes. And believe me, it'll make your life a lot easier, though it's a little confusing to explain why and how, so I have a diagram for you. Alright, picture everything on the screen right now as running on your machine. When we want to run our application, we have to package it up into a WAR file first. So this is going to be essentially a package of all of your Java code, your BRMS rules, your camel endpoints, as well as all of your UI code, all of your JavaScript, HTML, and CSS. So all of that gets packaged up into a WAR file, and you put it on the Tomcat server. Then, after your Tomcat server is running, you go over to your browser, open it up, and you should see your application. And for UI development, we'd go over and start our Node server, which is going to run simultaneously. However, it's different in the fact that our Node server is only serving up our static front-end files. So here we are with two different web pages open side by side. One is served up from the Tomcat server. The other is served up from the Node server. You notice, however, even though they're served from two different locations, they're both going back and communicating to the Tomcat server, i.e. they're communicating with the Camel REST endpoints that are running there. Remember, the Node server only serves up the static HTML, JavaScript, and CSS files to your browser so it can run. So the reason we're doing all of this for local UI development is to save you a lot of time and a lot of headaches. There's this clever tool called NodeMon, which you should go ahead and install via npm, that you'll use to run your Node server. When you use this tool, it monitors all of the files within the front-end code directory, and anytime you update a file and save it, the Node server automatically redeploys. Meaning that all you have to do in order to see that UI change in your browser is refresh the web page that is coming from the Node server. Without this setup, every time that you wanted to make a little tiny tweak to the UI and then see it in the browser, you'd have to rebuild all of your Java code and make it into your WAR file, put that WAR file onto the Tomcat server, and restart the Tomcat server. You can see how that can get tedious whenever you're making several tiny little tweaks. So yeah, essentially the only reason we're using a Node server in this project is to keep you from having to rebuild your Java artifact with every single UI change. Alright, now let's get into AngularJS. So the entire front end of this application is written in AngularJS, which means version 1.0. Angular is currently, I believe, at version 5 at the moment that I'm recording this video. However, most projects that you'll walk onto, if they already have a UI in place, it's not going to be using the most bleeding edge versions of UI technologies. So it is beneficial to be well versed in older or more stable versions. So Angular adheres to a design called MVC, or Model View Controller. Essentially what that means is that you have your data model, which is fed up through your controller and presented on the view. The view is just that. It's what you see in your browser. And the controller is the code just behind that, which manipulates the view and takes requests to and from. Angular also has two-way data binding. We'll take a closer look at that in a minute, but simply what that means is that you have your controller, which is written in JavaScript, and you can declare a variable on that controller that you can then reference in your view, which is your HTML file. Angular also has a concept of route configuration, which basically means you're just going to wire up some controllers to some routes. Route meaning the actual URL route that you see in your browser. It's just a way to get around from one page to another. And then you have directives, and that's where the controller and view relationship starts to get a little bit confusing. Essentially, a directive is a pairing of a controller and a view that doesn't have a route. So you're not going to navigate to it from your URL in your browser. Instead, the directive is packaged up and placed onto another view. So first you're going to have a view and controller that has a route that you can navigate to, and then on that view you'll have a directive, which is a reference to another set of view and controller. We'll take another look at that in our code base in a moment, so don't worry if it's confusing right now. Alright, next up there's services and factories. This is where the model aspect comes into this. They essentially communicate with your API endpoints, which are running on the Tomcat server. And then there is your app.js. So this is a file that's in every Angular application. It's a centralized location which declares all of your namespaces in the app and pulls in any external dependencies and gives them a namespace to reference. So let's say we had some kind of special button plugin that we want to use in our app. Well, we would declare that special button plugin in our app.js so that we can reference it in a controller somewhere else in the app. And finally, we have your index.html file. I know that says index.js, but that's a typo. Essentially, AngularJS apps are what's known as single-page web apps, which means you really only have a single web page the entire time, and then HTML is dynamically injected into the page or removed from the page. So your index.html file is that single page. And then, like any other web app, on that page you will be declaring all of your JS dependencies. You'll have your little script tags that pull in all of the JS files that you've written for the application, and then any other external dependencies. Alright, so before we actually jump into our front-end code base, I want to talk to you a little bit about JavaScript and promises. By its nature, JavaScript is asynchronous, which means it's non-blocking for I/O. So what that means is that if you have any I/O, such as maybe like a database query or a AJAX request, JavaScript isn't going to halt its execution. It's going to keep on going down your file and executing its code without waiting to hear back from the database or waiting to hear back and get a response back from a server. So promises are a way in which to say, all right, JavaScript, hold your execution up I want to wait and hear back from my database before I continue executing a certain block of code. It's also single-threaded, so you don't need to worry about things like I/O locks or semaphores. And it's also functional, which makes it really, really cool. You can do things like declare objects on the fly. You don't have to declare classes or interfaces or any of that stuff. You can use functions as objects. You can pass functions into other functions as parameters. You can have functions that create other functions and return functions, essentially function generators. So there's some really cool stuff you can do with JavaScript, and you'll see some of it in our code base. Let's go take a look at our index.html page. Here you see a lot of script tags, as I said, pulling in some external dependencies like the Angular UI router. You have some style sheets, some CSS, and all of the JavaScript files needed to run the application. So this is the app.js, which was our server. But if we go to core, we have another app.js. So this is the app.js that every Angular app has. This declares the global namespace. The name of this app is Ace Concerts. Then within it, you see we have our UI router declared. We have our spinner declared. So these are our external dependencies that we've declared. And then right here are the namespaces for the modules that we've built that are custom to our application. You see they kind of correspond to our file structure here: sections, components, and core. All right. And then right here, whenever the app starts, this actually runs the application. It's saying that we're going to go to the login page, and we're going to log out to the console. We are starting up the application. All right, now let's go take a look at the sections folder. In this particular folder, you have your views and controllers that have a defined route. So these are pages that you can navigate to in the app. You notice we only really have two pages. You have a login screen and a home screen. The reason we organize an Angular application like this by core, sections, and components is because it can give you a really good idea of what the app actually looks like and how it functions just by looking at the file structure. So sections, we see that we have two pages that we can navigate to. So let's crack open home.tpl, which stands for just template, .html, and then the home controller. Let's look at the two of these side by side. It's really important. So this is that two-way data binding I was talking about earlier, where you can declare a variable over here in your controller, and then you can turn around and reference it over here in your view. So you notice how we have vm.venues. So I'm setting up this object right here, this venues object, which has a CSS class attached to it, either active or nothing, which is inactive. And when I click the show function, it can actually reference itself and make itself active. So these really are just two objects which are going to control the tabs over in your view. You're going to have a venues tab and a performance tab. So let's go over here to the view and see how those interact. We have our ng. ng is Angular specific directives. Basically, Angular specific things that already exist are built out. So this is a way Angular lets you manipulate the class programmatically. So we have ng class equals home, which is our home controller, dot venues. So we're looking at this object right here, dot class. So we're saying that the CSS class of this HTML element is equivalent to whatever this object is saying it is right now. So that's the two-way data binding. And then we have ng click. So this right here is Angular's way of saying, all right, I want to bind a function that you've declared over here, like this show function over here in a controller. I want to bind that to an on-click event. So whenever the user clicks on a particular element in the view, I want to fire off a function over here in the controller. So ngClick equal home.venues.show. So whenever somebody clicks that tab, we're going to run this show function. Same goes for perfs, or performances. Whenever somebody clicks that upcoming performances right there, see the text, upcoming performances. So whenever somebody clicks that tag, then we're going to run this show function, right? Which makes the list of performances active. Okay, and then look down here. This right here is where we pull in our directives. So we have two tabs up top, one for venues, one for performances. And when you click them, one becomes active, the other becomes inactive. It's a hide and show kind of thing. And then down here, we actually have our list of upcoming performances and our list of available venues. Now you notice all that's here is a custom HTML tag which says performances and a custom HTML tag which is venues. So those two tags are directives. We have somewhere else in this app, we have a performances view and performances controller, which are bound together as a directive, and we're able to reference them on another view. And what this is saying, when Angular sees this tag, this is saying, hey, go out, find my performances directive that I've written, and pull it here. Put it here. Put the HTML here, and bind whatever HTML you put here to the corresponding performances controller that you've defined. Same with the venues. So let's actually go and let's take a look at these directives and see what they say. So if sections are the places where you can navigate to, like our home screen and our login screen, actually I'm going to back up for 1 second. Before we go and take a look at these directives, real quick, let's take a look at the route that is defined, because this is the home screen and you can navigate to it. So let's go look at home.js. Now, state provider is just the router that we're using. It's the Angular UI router that we're referencing. It's essentially saying that whatever page you're on is the current state of the application. So we're declaring right now this is the home state. So if I say state.go to home, that's where you'll be navigated to. URL is /home. Template URL. So this is the, how can I find the template that I'm going to use for this? How can I find the view? And this right here, www/section/home/view/home.tpl.html. That's this file right here that we were just looking at. Okay, so it says this piece of HTML, this view, let's bind this to this controller, home control, and we're going to reference it as home. So you notice back here, whenever we reference the class, right, or the show function, we said home.perfs. Well, that's actually established right here in the route definition. We're binding a controller to a view, and we're saying how we want to reference this controller. So we want to use this home control, which we've defined here in our controller, right, and that we've defined in our app.js namespace, right? Angular reads through your app.js at startup, goes and finds aceconcerts.sections.home, which is defined right here, right? aceconcerts.sections.home, and it says, okay, what do you need, module? Module says, I need this home controller, which is defined over here. So please pull in this home controller. And then Angular goes, okay, I'll use that namespace if it exists, and it looks through the list of files that are declared in the index.html, and it says, okay, do I have some file somewhere that is declared as aceconcerts.sections.home.controller, and it actually does. So you've pulled in this script, this homecontroller.js and this home.js, right? And so it goes, oh, okay, well, I'm looking through this JS file that I've already pulled in, and look, I have the right namespace right here. Okay, so that's what I'm going to need. And then it uses it. This file uses that by saying, over here on my route, I'm binding the home controller to this field, to this home template. Okay, so that's a route, and that's how you do route definitions. Okay, so now back to home.html, and we're going to look at, going to actually go take a look at these two directives. So first we're going to go into components. So sections is where you keep the places in your app that you can navigate to, and components is where you keep all your directives, essentially where you keep your reusable components. So let's crack open the performances.js. This right here is just defining all the namespaces. So we have a directive, we have an add, which is this add modal, success, which is this file, this folder, the success folder, and the failure. So essentially, the performances.js, it's a simple file. It's just saying, hey, for this top level namespace, I want to pull in all of these other components. All right, so let's look at the directive. So instead of a route definition, like we have for home, right? Instead of a route definition, like we have over here for home, we have a directive definition. It does a very, very similar thing, right? So we have our top level namespace, performances directive. We're going to pull in the performances controller, and then we're going to say, hey, let's make a directive out of this, and I want to use this view, the performances.tpl.html, and I want to use this controller with it. That's all it means. Bind to controller is true. So we want to bind these two together. All right, so let's take a look at the performances.html and see what we can figure out between performance controller and performance.html. So there's a lot going on in this controller. There's a lot of code. There's a lot going on. Okay, so let's take a look at what happens when this thing starts up, right? So we have some dependencies pulled in here at the top of the performances controller. We're going to be using a logger. We're going to be using a modal, which is just like a pop-up. We're going to be talking to the concert service. We're going to be using this thing called interval, and we're going to be using a spinner. Okay, and then you have some functions that are created, right? This is JavaScript, so you can assign functions to variables. So don't be scared when you see I have a variable and then boom. Oh yeah, okay. So this is also something to talk about. VM. Notice at the top of this, VM equals this. JavaScript can be really confusing when it comes to scope of functions, and this is just a common syntax that's used to simplify that. All right, so back to what's happening when you first start, or whenever you first navigate to this page. So notice the activate function is running, and then an interval is set up, and it says every 3,000 milliseconds, let's run this activate function once again. So this is JavaScript, right? So functions can be passed as variables. Functions can be treated as objects, essentially. So we can pass functions into another function. So it's essentially saying, like, hey, every 3 seconds, I want you to run this activate function. Let's see what it does. So this activate function is returning something. So you have the concert service, which is somewhere else in the app, right? It's a service. It's not a controller. Somewhere else in the app that we want to talk to, and we want to get the bookings, get the list of bookings from this concert service. So we're going to run this function, concert service dot get bookings, and then once that's finished, once we get a response from the concert service, I want to do something else. So this is how promises work. See, JavaScript is non-blocking for I/O, which means if I'm making a REST call, if I'm making an AJAX request, then JavaScript isn't going to wait to hear back from it. So I don't want to assign whatever this gets back to VM.bookings until I've actually gotten a response back. That's all promises are. So the concert service.getBookings function returns a promise. And the syntax for that is you have a promise right here, which this returns, then I want to do something. So going back, this directive, this performances directive, when it starts up, is grabbing a list of bookings from this concert service and then showing it on the UI. So right here, we have an ng repeat, which is essentially a for loop that says I want to show for each booking in performances.bookings, which is defined over here, vm.bookings. So I'm going to do a for loop, and for every booking in performances.bookings, I want to put this onto the view. So whenever the performances tab is active, I want you to show the performances directive, which is essentially just a list of the performances. Same thing goes for the venue. When I click on the venues tab, I want you to show the list of venues. Yeah, and so that's directives in a nutshell, and how our homepage works in this application. All right, so last thing we're going to go look at is that concert service that the performances directive is utilizing. So this concert service is a JS file. It's a service. It's not a controller, so it doesn't have a view that it's bound to, and it doesn't have a route. It's not a directive, right? It's a service. This guy's responsibility is getting the data model and the data from the back end, so from our camel endpoints. So notice how I'm setting up this variable camel, which references the location of the camel endpoints, and I'm just adding on is the API endpoint location. So it's at the camel location / booking / venue / performances. I want to hit the bookings camel endpoints or the venues camel endpoints, and I'm creating an object from that. So $resource creates an endpoint for me based off of that location, which is the booking endpoint, and then I'm using some functions on that object to make my AJAX requests. So .save, .query, those are firing off AJAX requests and returning promises. You see the $promise converts the response into a promise, and so then we can start our promise chain with the .then and return res, which is just whatever response we get back from our server. So in this get bookings, that res is going to be hopefully the list of bookings that we get back from our server. All right, so at a high level, that's the application. If you've made it this far, thanks for hanging in there, and feel free to reach out with any questions.